Hi friends, welcome back. Continuing our discussion on monostable multivibrator, let us see how this model can be converted into a transistorized circuit. Yes, there is the inverter circuit. This is our inverter circuit for inverter 1, and for inverter 2 we have a similar circuit, but only thing now we don't require these two because these are being taken care by the capacitor and resistor here. How they do, let us check out. So this is our one NOT gate, this is our another NOT gate under control of R and C, and this our feedback. So doesn't look very impressive, so just get the mirror image of this. So this is what you look. So there's nothing different. So the Q1 base is connected to the collector of Q2 through R1. Q1 base is connected to collector of Q2 through R1. So Q1 base is connected to Q2 collector through R1. Q1 base is connected to minus VBB through R2. Q1 base connected to minus VBB through R2. Then Q1 collector is connected to Q2 base via C. So Q1 collector is connected to Q2 base via C, and Q2 base is connected to VCC via R. Other than rest all is same. Now how does this work? So when under normal condition this will be on, so output will be low. So under normal condition this will be on, this will be off. This is on, therefore the voltage here is low, and this low voltage ensures the Q1 is off. Q1 is off means this voltage is high. This voltage is high, and you don't want capacitor to change its value, then this value will also be high. So that ensures the second transistor to be on. So this is in stable state now. To disturb it, yes, apply a negative pulse here. So for a moment this goes low. When this goes low, capacitor voltage cannot change. Therefore this point suddenly goes low because this was already VCE saturation, so almost zero point 0.7 volt. And when you apply voltage more than zero point 0.7 voltage drop, then this is confirmed to go negative, and hence it's confirmed that this transistor gets off. And once this gets off, this voltage goes high, and this high will make sure to turn on this transistor, and the moment this transistor is turned on, this output goes low, and the moment this output goes low, there is path for current to flow because this is high, this is low. Earlier this was also high, this is high, so there was no chance of current flowing. But the moment this has gone low, the current starts flowing, which charges this capacitor, and because it charges this capacitor, the voltage here which had gone negative deep down will go exponentially up, and finally it turns on the transistor. And once the transistor turns on, the output goes back to 0, and this goes back to 0. The output is 0. Will confirm that this is off. If this is off, then this will be high. If this is high, then this keeps the Q2 on, and that's the process. Now, why do you require this circuit? Was to ensure that the transistor goes into cutoff. In this side, we don't require a negative supply pulling it down, because the capacitor is there to ensure to give a negative voltage. Whenever we apply a negative pulse here, then this voltage suddenly drops, and this was on means it was almost zero point 0.7 volts for a silicon transistor, and this goes low by some 5 volts, then zero point 0.7 minus 5, it goes down to minus 4.7. Whatever it is, the negative voltage confirms that the base emitter junction is reverse biased, which confirms that the transistor gets into cutoff for sure. And once it is cut off, this voltage goes high. If this voltage goes high, then this current starts flowing and this becomes on. Then this goes low, then we don't require any more pulse here. This low is sufficient to keep this off, keep this on. That continues, but becoming a zero here, current starts flowing, and that is an automated process, and that ensures that this is going to remain off only for a fixed period controlled by R and C values. And that's the monostable multivibrator. More things to come. Till then, take care. See you. Bye.